Okay, question 7 then. We need to find a set of values which satisfy both inequalities. So let's do them both separately and then we can compare. So the first one, I need to factorise that and do my sketch of a graph. So that will be x minus 3 and x plus 2. And I want to know where that is bigger than 0. So this is going to cross my axes at minus 2 and positive 3. And I want to know where it's bigger than 0, which is here and here. So the inequality for that is x must be less than minus 2 and x is bigger than 3. I look at my second inequality. This is a nice one to solve. I've got 10 minus 2x is less than 5. Well, I'm going to add 2x to each side to get rid of that negative. And then I'm going to take 5 from each side to get 5x. Divide both sides by 2, I'll get x is bigger than 5 over 2, or x is bigger than 2.5. And the easiest way to do this is to now think about both of these on a number line. So this first inequality, if I think about that on a number line, I would say that is when x is less than minus 2, so that's that way. When x is bigger than 3, so that's that way. And the second inequality is when x is bigger than 2.5, so that would be about there, wouldn't it? So 2.5 and bigger. And all I'm asking for is where are both inequalities true? So whereabouts on my diagram are both things the same, or both true, both lines? And it's got to be from there up. So from there up, both of them are true, aren't they? So the final answer is both inequalities are satisfied when x is bigger than 3. Okay, question 8 was a nice simultaneous equations one. So if I rearrange the top, it was x plus 2y equals 3. Well, I can rearrange that to get x equals 3 minus 2y's. And I'm going to substitute that value for x into this equation up here. So instead of it being x squared minus 4y equals minus 33, I'm going to put that in place of the x. So I'm going to have 3 minus 2y squared minus 4y, oops, I missed the squared above, minus 33. So multiplying this out, and multiply this out, I'll get 9, I'll get minus 6y minus 6y, so it's minus 12y, plus 4y squared, minus 4y squared, equals minus 33. Simplifying the left-hand side, plus 4y squared minus 4y squared is no y squared. Should have 9 minus 12y equals minus 33. 9 equals minus 33 plus 12y. Add 33 to both sides. 42 is 12y. So y must be 42 over 12, which is the same as 21 over 6. Which is the same as if we divide both sides by 3, 7 over 2, or if you like, that's 3.5. So y is 3.5 in this case. And all you need to do at that point is say, well, if y is 3.5, putting that up into this equation, 2 3.5s would be 7. So if y is 3.5, then x must be 3 minus 7. So x equals minus 4. So your final answer is y equals 3.5, x equals minus 4. So question 9, I've spotted it's another inequality. So what I'm going to have to do is multiply out this inequality, make it bigger than or less than 0, and then do my graph sketching. So multiplying out my inequality, I'm going to get 2x squared plus 4x minus 3x minus 6 is bigger than 3x minus 6. This side simplifies to 2x squared plus 1x minus 6 is bigger than 3x minus 6. I can take the 3x's from both sides, so I get 2x squared minus 2x minus 6 is bigger than minus 6. Add 6 to both sides to make this one a 0, and we get 2x squared minus 2x is bigger than 0. If I want to sketch this as a graph, I need to factorise it. So common factor in both of these is 2x. It's going to be 2x brackets x minus 1. And I know that this is going to cross the axes at the value of x that would make that 0 is 0, and the value of x that makes that one 0 is 1. So it's going to cross at 0 and 1. And I'm asked where that graph is bigger than 0, so that's that bit and that bit. So my inequality for this one is that x is less than 0 and x is bigger than 1. Lastly, question 10. Again, another inequality. So I know I need to make it 0 and sketch the graph. So if it is x brackets x minus 5 is bigger than 36, I can say that x squared minus 5x has to be bigger than 36, or x squared minus 5x, take 36 from both sides, and I'm left with that is bigger than 0. So two numbers that multiply to give this and add to give this, well, that's got to be x minus 9 and x plus 4. So this graph is going to cross the axes at minus 4 and plus 9. And where the graph is bigger than 0 are these two bits. So your inequality is that x is less than minus 4 and x is bigger than 9. Part B then says, using your answer to part A, solve or find the set of values for this. So hopefully you can see in set A, from A, that all we've done is replace the x with y squared. So for part B, that inequality is satisfied if x squared is less than minus 4, or y squared even, or y squared is bigger than 9. So can a square number be less than minus 4? Well, the smallest square number we can get 0. We can never have a square number to be a negative. So that one is impossible. So we can't have that one. It's not possible to have that one. We can get rid of that one. So the only values of y that work are this one. And again, it's a quadratic, so we make that bigger than 0. This is a difference of two squares, so it's y plus 3, y minus 3 is bigger than 0. And a very quick sketch of this graph will show you that that crosses at 3 and minus 3. And if I want where it's bigger than 0, it's there and there. So either x is less than minus 3 or x is bigger than 3. Oh, sorry, not x, y. My mistake. Y is bigger than less than 3, or y is bigger than less than minus 3 or bigger than 3.